Okay, here's our second video on scientific notation, part 2. So let's just review. Remember, in scientific notation, we can make very large numbers smaller. All right, for example, let's look at this number here. So we can create, let's make the periods first. Every 3 is a period. Right? So we have this very large number here. How do we put that in scientific notation? Try that. Okay, so remember, it has 12 numbers past the first number here. There are 12 numbers, so we know this is 3,409,000,000,000, right? So with scientific notation, remember, we put the first number 3, and we put every number. Now we have to include the 0 because there's the last number that's not a 0 is a 9, so we have to include that 0. If the 9 wasn't there, we wouldn't include the 0. So we include all the numbers that are higher than 0. But if a 0 is a bit in between any numbers higher than 0, we have to include it. And we know with powers of 10, its scientific notation is based on powers of 10. Let's count the numbers. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We don't count the first number, so this will be that. So we've taken this large number and we made it into scientific notation. Okay. Now sometimes we can take a number that's already in scientific notation and we can put it into standard form. So all you have to do is look at the exponent. The exponent tells you everything you need to do. Here's the decimal. We move it 4 times. 1, 2, 3, 4. And we have those waves. And if the waves are empty, we add zeros to them. All right, 23,000 will be 2.3 times 10 to the 4th power. Okay. Now let's see if you can do this one. Okay, the exponent tells you again everything you need to do. It's telling you to move the decimal 4 times. 1, 2, 3, 4. And whatever's empty in these waves, just put zeros. 12,200. Now, what if we had a number like this? This is a decimal. So we look for the first number that's not 0. It's 4. So we know we're going to have a 4, and we're going to times it by 10. But again, we don't want to go to the right now. We want this decimal, which is here now, to go this way. Bring that over. So the decimal's here, and we want to get it to here. So let's count the spaces. 1, 2, 3, 4, 5, 6, 7. 7 spaces. So this will be 4 times 10, not to the 7th power, but to the negative 7th power. So when you see a negative 7 exponent, you go to the left. If it was positive, you go to the right. So this is in scientific notation, and this would be in standard form as a decimal. Okay, let's see if you can do one by yourself now. Try this. Put this in scientific notation. Now it's a little tricky because you have these zeros. So you have to start with the first number you see going this way, so 3. Scientific notation has to have a decimal after the first number. We have to use these zeros because there's a 5 at the end. Okay, and we always times it by 10 in scientific notation. Now if the decimal was here, how can we get it to there? How many spaces do we have to move? 1, 2, 3, 4. And it'll be negative 4. Okay? And again, we have a standard form and in scientific notation. So here's one that's already in scientific notation. How would you put it in standard form? Again, the exponent tells you all you need to do. The exponent right here is telling you to move it to the left 4 times. Remember, it's a negative 4. So let's write it over here. Move it to the left. 1, 2, 3, 4. And whatever's in these waves that are empty, put zeros. There should be 3 zeros. Okay? Now, some common mistakes students do is they have a decimal here and they put 2 decimals. Remember, you can never have 2 decimals. So that decimal is moving. So this is in standard form. What if we had in word form? Part word form and part number. How would you write 244 billion in scientific notation? Try that. Okay, well again, always with scientific notation, we use the first number. It's 2.44. And we're timesing it by 10. Now what is billion? How many zeros are in billion? If you want, you can write this out. Let's write 244 billion. Here's 244. That's 244,000. That's 244 million. And there's 244 billion. So it may be easier to write it out first. Right, so here's 244 billion. We know we have the decimal after the first digit. And then count the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 numbers. If we move this 11 times this way, we'll get it, the standard form number. Right? So let's say it was here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Now here's one that could be a little tricky. 2,300 millionths. Remember, the THS means it's a decimal. 2,300 millionths. First, you should write it out. So as a fraction, 23, and you want 100 millionths. 100 millionths, that's the fraction. So what would the decimal be? Then once you get the decimal, put it in scientific notation. Try that. Okay, let's bring it up here. So as a decimal, we'll write it up here. We'll keep going. This is, if we put the decimal here, we'll have it in the 100th place. Well, this will be the 1,000th, 10,000th, 100,000th. Remember the TH. So 10, 100, 1,000th, 10,000, 100,000th, millionth, 10 millionth, 100 millionth. So there is the decimal now, 2,300 millionth. So again, with scientific notation, we're going to take the first number 2, put a decimal, put a 3. We don't put zeros unless the 0 comes before one of the numbers. We want a negative now. So if the decimal was here, how many spaces? 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. Okay, so that's in scientific notation. Now keep in mind, sometimes you can get a number that's not in scientific notation, but it looks like it. So let's say you had 25.3 times 10 to the 5th power. Now that's not in scientific notation, but it is using powers of 10, so it's a perfectly good number. But remember, in scientific notation, the decimal has to come right after the first number. Now if this was 10 to the 5th with a decimal there, that means you're going 5 spaces this way. But if you have to put the decimal there, that means you're losing a space. You have to add a space. So it'll be 10 to the 6th power. So what if I had this? What if I had 367.4 times 10 to the 7th power? Again, it's a perfectly good number. It's using powers of 10, but it's not in scientific notation. So in scientific notation, again, you have to put it there like this. And you would have to go 7 this way for that top number. But now, the decimal was moved back 3 times, so you have to add 3 more to it. So that would be the answer in scientific notation. Okay, actually, not 10. Get that 10 out of the way. If the decimal is here, we got to go back 2 more spaces, so there'll be 9 to the 9th power. Okay, always double check your work to make sure. Again, if that's where the decimal was in the beginning, we only have to go back 2 spaces. So now we have to add 2 more spaces when we go this way, and it'll be to the 9th power. Okay? Okay, and in part 3 of scientific notation, we'll talk about how we can multiply them together. Great job.